Okay, so before we just get started, I just want to test, is my mic all fine? I want to make sure everyone can hear me okay. So let me know if I can't be heard properly. Okay, so basically in the next roughly 2 hours, we're going to go over pretty much everything that can come up in the higher GCSE. So if everything's all good, then we'll get started. So if you have any questions or anything like that, just let me know in the chat and I'll try and respond to them. So starting off, we have this first one, which is a common thing you need to do. So it's expressing recurring decimals as a fraction. So for this question, what we do first is, when we have something like this, 0.017 recurring, we let x equal that thing. So 0.017 recurring. And sorry, I wrote it wrong. Let me know if I make any mistakes, by the way. So we write it like this. And now what we do is, once we have this, we write out the recurring fully. So what we're gonna do is write out this 17 like as the recurring. So we're gonna put 1717 and then that just continues, obviously. Now what we need to do is we need to multiply x by something so that all this recurring nonsense will cancel out. Now in this case, what we want to do, okay, yeah, this is higher, by the way. So what we want to do, so I'll just put higher just to make it clear. Okay, so what we're gonna do is we want to find some way that we're gonna get 1717, so some lot of x equals something point that and then something point 1717, and then we take them away from each other. So what I mean by that is, notice if we multiply this x by 10, we get 10x is equal to 1 point, so this goes over here and everything shifts to the left by 1. So we have this and that continues. Now what we want to do is find another multiple of x which again has the same decimal pattern. So if we multiply x by 1000, so what we are going to do is just shift everything 2 more to the left. So what we're going to get is 117.1717, and then that is continuing. So now what we do at this stage, if you notice, if we subtract these two, then what we're getting here is 1000x take away 10x, which is 990x. And then here, these recurring decimals are just going to cancel each other out. So these are going to disappear, and we're just left with 117 take away 1. So we have 116. And now at this stage, I'm sure you know how to find x. We just divide both sides by 990. So now we get this as our final answer. Now we can also simplify this. So what we can do is divide the top and bottom by 2. So we can get 58, and then 990 divided by 2 is just going to be 495. And then we can just leave it like this. Okay, so that was the first question done. Now let's move on to the next one. So by the way, this is mostly aiming at higher stuff, so it's, if anyone's wondering, it's mostly higher stuff. I'd say grade 6 and all the way to grade 9. If you have any questions, let me know, I'll try and answer them. So in this next one, we have something very common, which is with surds. It's basically guaranteed you're going to have a surds question in the paper. So in this one, what we want to do is show that this can be written in this form, which in other words is just saying rationalize the denominator. So what that means is get rid of the surd from the bottom. So what we do for questions like this is, so we write down our original thing. So when we have something like this, what we're going to do is multiply the top and bottom of the fraction by this, but we replace the plus with a minus sign. So we have 5 minus root 3, and we're multiplying the top and bottom by that thing. So now what we're going to do is just compute this calculation. So on the top we have, so I'm just writing it in brackets at the moment, we have this right here, and then on the bottom we have 5 plus root 3 times by 5 minus root 3. Now what we're going to do is go down here and write what that's actually equal to. So if we look at the, what did I do? Okay, so if I just get that back up there. Okay, so on the bottom of the fraction, we're just going to multiply this out. So we have 5 times 5, that's 25. Then we have 5 times minus root 3, so minus 5 root 3. It's very important to remember your like surds calculations here. And then we have root 3 times 5, so 5 root 3. And then we have root 3 times minus root 3. So that is minus root 3 squared. And that's the same as just saying 3, because the square root and the squared are going to cancel each other out. So this is what we have on the bottom of the fraction. And if you notice, this can be simplified because what did I do? So if I undo that, so this cancels out with this, so we can just delete those, and then we have 25 minus 3 left on the bottom, so that's just 22. And then on the top we're going to expand this, so we have 8 times 5, which is 40, then minus 8 root 3, and then plus 5 root 12 minus, then we have square root of 12 multiplied by square root of minus 3. Remember, when doing square roots, when you have one square root multiplied by the other square root, so root a times root b, then that is just equal to root ab. So we have square root of 36. So now if you notice, square root of 36 is just 6, so you can write that. So what we have right now is 40 minus 6, which is 34, plus 5 root 12 minus 8 root 3, and that is all over 22. Now if you notice the question, it wants it in this form, it wants it plus root 3, and if you look at what we have root 12 and root 3. So all we need to do is change this root 12 in terms of root 3. So this is how you do that. So you write, if we look at root 12 here, so I'm just going to do this to the side, what we need to do is split up 12 into two factors where one of them is a square number. So what I mean by that is we can split up root 12 as root 4 times root 3, because notice 4 times 3 is equal to 12. So we're saying square root of 12 is equal to root 4 times root 3. But what do you notice about root 4? That is just equal to 2. So square root of 12 is the same as 2 root 3. So that means 5 lots of square root of 12 is going to be equal to 5 lots of this, so 10 root 3. So this 5 root 12 becomes 10 root 3. Now what we do here is just simplify this, and this is edXL, by the way. It applies for all the exam boards, but okay, I don't know why I said edXL, but edXL is what it mainly goes for, but it works for all the exam boards, I'd say, because these questions are past exam questions from majority edXL and then some from other exam boards, so it should work for everyone, to be fair. Anyway, let's continue with this question. We have 10 root 3 minus 8 root 3, so that's just 2 root 3. So we have 34 plus 2 root 3 over 22. And now what can you do? Well, all you need to do in the final step is just notice that the bottom numbers and the top numbers can be divided by 2. So we get 17 plus root 3 over 11. And that's our final answer. And it's given like the exam board, like they say here. And this would probably be around 4-5 marks, these sort of questions, but it's very important. One more thing I'd like to mention, so this is one way of rationalizing the denominator of surds, but something else they can ask is, let me just get it here, so what you could have is an easier version, which is, let's say we had 2 over root 3, and it said rationalize that. Well, in this case, all we need to do is multiply the top and bottom by the square root we have. So if we have 2 over root 3, all we need to do is multiply the top and bottom by root 3. So at the top, we're getting 2 root 3, and at the bottom, we're getting root 3 times root 3. So that's square root 3 all squared, which is the same as 3, because the square root and the square will cancel each other out. So this is another type of thing they could also ask. So moving on from that, let's scroll to the side. So let me see if it lets me. Okay. So for this next question, we have this. So this is another important point you need to remember. So if you have, my pen's not working. Okay, it's working now. So so find the value of 4 times sine 30 times tan 30 times cos of 30. So these are common questions that can come up, and this is involving exact trig values. So that's something you're going to need to remember for your exams. So a quick table, which I'll just quickly draw up for the exact trig values, looks something like this. So the angles you have to remember them for are 0, 30, 45, 60, and then 90. And then this is obviously for sine x, cos x, and tan of x. So what you get here is, I'm just going to fill it out, but you just got to remember this for your exam. So what I'd recommend is probably look at this the day, like literally an hour or two before your exam, just to make sure you fully memorize this. So for the first column, sine of 0 is equal to 0, cos of 0 is equal to 1, and tan of 0 is equal to 0. And then if we continue filling out this one, we have for 30 degrees, we have this. And then for 45 degrees, this is where sine and cos are the same. So for 45 degrees, they are both 1 over root 2. And tan of 45 is 1. And for 60, we have root 3, 1 over root 2, and then 1 over root 2. And then for 90, we have root 3 over 2, a half, and then not root 3, sorry. Sorry, I put the wrong numbers here. So for 90 degrees, wait a second. Yeah, I put the wrong thing, sorry. Let me just correct this. So for 60 degrees, what we have is root 3 over 2, a half, and then root 3. And then for 90 degrees, we have 1, 0, and tan of 90, that's just undefined. You can't have a value here. So this is in preparation for tomorrow's exam, which is non-calculator, which is why I'm saying you have to memorize these, because all these questions are non-calculator questions, so you're expected to do them without a calculator. So anyway, if we now look at the question, we have 4 times sine of 30, well that's just a half, so we have 4 times a half, then tan of 30, which is 1 over root 3, and then cos of 30, which is root 3 over 2. So now if we simplify this, well notice we're getting a lot of cancelling out. So we have, if we look at this here, 1 over root 3 times root 3 over 2, well the root 3's are going to cancel each other out. So all we're left with is 4 times a half times these two will combine just to give a half. And if you simplify this, you're just going to get 1. So that's your final answer. That will be the answer for this. So if we move on to the next question. Okay. So here are some more important things that you sort of need to remember. So this is to do with graphs. So there are a few graphs that you need to generally remember the shape of. So I'm just going to draw some quick axes. So I won't label them X and Y, but I'm sure you know what I mean. So if I just draw a few. So first of all, you have quadratics, and what they're going to look like is either a U shape or this sort of N shape. So this would be for y equals negative x squared, and this would be for y equals x squared. So if it's positive x squared, you're going to have a U shape, and if it's negative x squared, you're going to have this sort of N shape. Now, there are also some other ones you need to remember. So, what you can have is this sort of graph, and this is y equals x cubed. So x cubed, you get sort of this weird shape. I don't even know what shape you'd call this. So that's for x squared, and then there's one other common one, which is when you have this. So this is y equals 1 over x. And if you notice, for this graph, you are never touching the axes in any of the places. And that's just because if we look at, for example, why we never reach x equals 0, that's because if you have 1 over x, you cannot sub in x equals 0, because this does not make sense. You can't divide by 0. So that's why the graph has these weirdish features, like it doesn't really touch the axes. It never touches them. So these are the main shapes that you need to remember. And there's also a few other ones. So these ones I'm going to draw a bit bigger. So you have x and y. So this is a sine graph, which looks like this. Then you have a cos graph, which looks like this. And what you need to remember is it's 360, 180, 90, and 90. And it reaches a minimum point of -1, max point of 1. So this is sine x, and this is cos x. So these are just some graphs you need to remember. So if I put all the points. So now let's look at some more questions. So these are just some quick points I wanted to make. So looking at this next question, here it is. So these are some indices questions which are quite important to do. So if we look at these two, which are more important, I'd say, first of all, we have find the value of 64 to the power of -1/2. So what we do here is we notice that we have two things. We have a fractional power and a negative power. So we deal with them one at a time. So first of all, let's write it like this. 64 to the power of -1/2 is equal to. So first of all, let's deal with the negative power. What does negative power do? Well, it just makes you get 1 over that number. So we have 1 over 64 to the half. Then at this stage, you just deal with this fractional power. So what does a half to the power of a half mean? Well, that means take the square root of it. So we have 1 over square root of 64, which is just equal to 1 over 8, because square root of 64 is 8. Looking at this next one, we have write this thing as a power of 3. So how do we do this? Well, if you notice, the top is already 3 to the n, but the bottom is written as a power of 9, so we need to fix that. So if we look at the top, we have 3 to the n, but then at the bottom we have 9. So how can we change 9 to 3? Well, notice 3 squared is equal to 9. So 9 to the n minus 1, we can just replace that with 3 squared, and then that is raised to the power of n minus 1. So like this. And when you have a power raised to another power, you just multiply the powers. So at the bottom we have 3 to the power of 2 times n minus 1. So now how you calculate this is you do, if you remember, when you're dividing powers, you're going to do this one, the power of this one, take away that one. So you have 3 to the n minus 2 to the n minus 1. So if we just simplify that, we get 3 to the n minus 2n plus 2, which is 3 to the 2 minus n. And that will be our final answer. So if we move on to the next question now. Here it is, I believe. Yeah. Okay, so in this next question, we have a padlock. So we're told there are 3 dials on a combination lock. Each dial can be set to 1, 2, 3, or 4 or 5. the 3-digit 553 is one way that the dials can be set, so that's just an example. And we want to work out the number of different 3-digit numbers that we can have for this combination lock. So we just want to find all the combinations for this. So what we do here is we need to find a way to count all the different amounts. So if we look at this one, so let's look at it here. So we have 3 positions for this padlock, and each one can take a value 1, 2, 3, 4 or 5. So each one can take a possible of 5 values. So we have 5 options here. So I'll just write options. We have 5 options for the second digit and 5 options for the third digit. So what we do to find the total number of combinations, all we need to do is just multiply these 3 numbers. So our answer is 5 times 5 times 5, which is just 5 cubed. So there are 125 different combinations that we can have. So that's part A of it. And now in part B, we have, so we're being asked how many of the possible 3-digit numbers have 3 different digits. So in this case, if I zoom out a bit, so what it is saying is, for example, if we have 1 as our first number, then for our second and third number, we cannot use 1 again. So it has to be 3 different numbers. So if we used 1 for the first option, we could do something like 2. So now if we've used 1 as the first option and 2 as the second, for our third option, we can only choose 3, 4 or 5. So something like this is a possible combination. Now, how do we find the total number of combinations? Well, what we're going to do is a similar thing to the previous question, to part A. We're going to look at how many options you can have for each one. So you're going to do, and somebody said in the chat, 60, which let's see what we get. So what we do first is we see how many options we have for our first digit, and that is 5 options because we can choose numbers from 1 to 5. But once we've chosen our first number, for our second digit there's going to be 4 options left because we can't choose the same option as the first one. So now we have 5 times 4, and then for the third option we can't use what we used here or here, so we're left with 3 options. So we do 5 times 4 times 3, which is just going to be equal to 60, and that will be your final answer for that one. So that's this question done. Let's move on to the next one. So let me just see what our next one is. Okay, so this next one is on ratios. So we have let me see, actually no, this next one's not ratios. If I scroll down, this is our next one. So this is just a expanding brackets. So this is a key thing that you need to be able to do. So what we have here is expanding triple brackets. Now, if you remember how you expand triple brackets, well, what you do is first you expand any of the 2 brackets, then you expand that result with the remaining bracket. So it doesn't matter if you expand the first and second bracket first or the second and third, you can do whichever one you want. But I'm going to do the first and second brackets. So if we first go about expanding these 2 brackets, what we're going to get is 2x squared minus, so we have minus 6x here, and then we have plus 3x. So we have minus 3x and then minus 9. So we've expanded the first 2 brackets. And then what we need to do is multiply this with the third bracket. So now that we have this, we just need to expand these 2 remaining brackets. So what we're going to do is first do 2x squared and multiply it by those 2 terms. So we get 4x cubed plus 10x squared. Let me know if I make a mistake, because it's very possible to make a mistake here, which is why in exam it's very important to keep looking over your answers. So now we do that, we just expand this bracket basically. So we have minus 12x squared minus 15x, and then we have minus 36x and then minus 45. And now what we're going to want to do is just simplify this whole thing. So we have 4x cubed and then 10x squared minus 12x squared gives us negative 2x squared, and then we have negative 15x take away 36x, which is 51x, and then we have negative 45, and that will be our final answer for that. So let's move on from that. Next, what we have is proportions questions. So if I write down the question quickly, so y is directly proportional to x cubed, and we're told that y equals 17 when x equals 4, and we want to find an equation linking x and y. So how we do these proportion questions? Well, there's two things that can happen. Either it's directly proportional or inversely proportional. So what we do first is we need to find the constant of proportion, because first of all, what does directly proportional mean? Well, that means if y is directly proportional to x cubed, we have y equals some constant times by x cubed. Now, if it had said it's inversely proportional, it'd look like y equals k over x cubed. So it'd look like that. But because it's inversely proportional, we have the first case. So now what we need to do is just find k. So what we're going to do is sub in these two values. So when x equals 4, y equals 17. So we have 17 here, and on the right side we have k times 4 cubed. So all we need to do is calculate 4 cubed, which is 64. So we have 64k equals 17. So we can divide both sides by 64, and we get k is equal to 17 over 64. So now we can just write our final equation, which is y equals 17 over 64 x cubed. So we're just replacing k with this, and that will be our final answer. So moving on from that, we have, let's just see, just double checking something. Okay, so now what we have is a question on proof. So here it is. We're told that given that n can be an integer such that n is greater than 1, prove that n squared minus n is never an odd number. So for these proof questions, what you need to remember is how you can represent an even number and an odd number. So any even number can be represented by two lots of n. It's because if you think about it, any even number is divisible by 2. Now an odd number can be represented by 2n plus 1, and this is just something you need to remember. So once you've written this down, you just use what the question's telling you. So we're told in the question, prove that n squared minus n is never an odd number. So we want to show that this is not an odd number. So let's look at this here. So n squared minus n. Now, when you look at these things, what you want to do is try and factorize it or something like that. So if we factorize it, then we're getting this n times n minus 1. So what do we have here? Well, if you notice, n and n minus 1, they're two consecutive numbers, because let's say n was 10, we'd have 10 and then 9. So it's two consecutive numbers. Now what's important about two consecutive numbers is that one of them will be even and one of them will be odd, because that's how numbers work, obviously. Because if you write 2 and 3, for example, 2 is even, 3 is odd. If you have any two consecutive numbers, it's going to be odd, one of them, and one of them is going to be even. So what we essentially have here is an odd number times an even number. And now we want to just explain why an odd times even is not an odd number. So what we can do is just replace odd and even by these two things. So we have 2n times 2n plus 1. And then if you expanded that out, you're just going to get 4n squared plus 2n. but more importantly, how you can show this is even is you can factorize it, and this can be factorized as 2n squared plus 2 lots of 2n squared plus n. Yeah. So this is an even number because it's written in that form. It's 2 lots of something. So that means this is always an even number, therefore it can never be an odd number. So you'd basically write something along the lines of that. Okay, so doing that question, let me just see in the chat. So this isn't a recording, by the way, it's live, so if you have any questions, just let me know. I'll try and answer them. Okay, so people are asking about factorization. We'll also be going on to that very soon, by the way, so don't worry. Moving on from that anyway, let's see the next question. Okay, yeah. So now we're going to move on to something that's very important in my opinion, and that is basically the whole concept of quadratics. In your exam, it's basically guaranteed you're going to get stuff on quadratics. So if I write here, we're just going to be quickly looking at quadratics in general. So what we have here for a quadratic, what we need to be able to do is factorize it, solve them, and also sketch them potentially. So first of all, let's look at a basic one. So let's say we were told to solve this thing here, x squared minus 6x minus 27, and that is equal to 0. So what we do in this case is we look at this third number, which is minus 27. So we write down this here, and what we want to do is find factors of 27 that add to give this, and obviously multiply to give minus 27. So let's write some factors of negative 27 and see which one works. So we could have something like 9 and negative 3. So let's see if this works. 9 minus 3 is equal to 6, but we want them to add up to negative 6. So this is not going to work. But notice if we flip it around, so we have negative 9 and 3, then these two numbers will add up to negative 6 and they multiply to minus 27. So this can be our factorization. So we're just going to get x. So what we do once we found our two numbers is we write brackets like this, and then we fill in these missing numbers with these two here. So we have x minus 9 and x plus 3. And now what we do is just set each one of these brackets equal to 0, and that will be our solutions. So we have x minus 9 equals 0 and x plus 3 equals 0. So our solutions are x equals 9 and x equals minus 3, and that will be our final answer. So now we've done that, let's look at a more difficult one. So if I go over here, here's another one. So solving this one here, 2x squared minus x minus 15, and that is equal to 0. So if I scroll over here, so we're told to solve this. Now this is where you can use something that's very important to have memorized, which is the quadratic formula. So if I write it down, we have x equals this thing right here. So this is just something you need to remember. And what these letters mean, well, a is the number here, so that's 2. B is the number in front of the x, which is negative 1 in this case. And C is just our constant term, which is negative 15 here. So now we're just going to plug all these numbers into our formula. So we have x equals minus b, so we have minus 1. Then we have plus or minus b squared, so minus 1 squared, which is just 1. And then we have take away 4 times a times c. And then we have this whole thing divided by 2 lots of a. So now what we're left with is, if you notice, we have negative times negative, so that's just 1. Then we have 1 plus or minus. So we have 4 times 2 times 15, which is equal to, let's just see, that is equal to 120, and there's also two negatives, so that's positive 120. So we have one takeaway 120. So let's just wait a second. I think I might have put this in wrong. Let me just double check this. Have I labeled the things wrong? I feel like I've done something wrong. Wait a second. So what we're left with here is basically, what have I put in wrong? I've forgotten something, I think. B squared minus 4AC. So we have 1, oh yeah, sorry, we have 1 plus 120, and then that is all over 4. Yeah, my brain just stopped working for a second. So what we're left with here is 1 plus or minus square root of 121 over 4, which is square root of 121 is just 11. So we either have 1 plus 11 over 4, which is 3, or 1 minus 11 over 4, which is minus 10 over 4. So our solutions are x equals 3, x equals minus 10 over 4. So in terms of most important topics, what I'd say is probably quadratics. Definitely make sure you can do that. Like, you can solve them any types and you can use the quadratic formula. Other things that I'd recommend is having a basic understanding of vectors, being able to like find different vectors. Another thing is, to be honest, there's a lot of different things, but one thing I'd also recommend is being able to simplify surds, so that's very important. And just in general, your algebraic skills, so being able to expand brackets, factorize things, add different fractions, so those things are just very important in general. And speaking of adding fractions, this is where we move on to a few important questions. So this next one we have, solve x over x plus 4 and then 7 over x minus 2, and that is equal to 1, and we just want to solve this. So what we have here is fractions and we need to add them. So the way you add fractions is you need the bottom of the fractions to be the same to be able to add them. So what we're going to do is try and make the bottom of the fractions the same. So what we do is we multiply this fraction by the bottom of that fraction. So we're going to have this thing here, and we're going to multiply the top and bottom by x minus 2. And then we do the same thing for the other fraction. So we have this, and we multiply the top and bottom by x plus 4. So we have this, so we're just multiplying that, and then we just expand this and simplify. So if I expand this, we get something like this on the top, and then on the bottom something like this. And then we just need to expand and simplify this a bit. So we have x squared minus 2x, and then 7x plus 28. And then we have this whole thing like this. So now that we've done this, what we do is we look at how we can actually solve it, because remember this was equal to 1. So this is equal to 1. So now what we're going to do, once we've combined these fractions, is we just bring over this whole term to here. So we're multiplying both sides of the equation by this. So we have x squared, so I'm going to simplify this. So x squared plus 5x plus 28, and that is equal to this thing right here. So now what we do is we expand this. So we have, on this side we have x squared plus 5x plus 28, and then here we have x squared plus 2x minus 8. So now what we need to do is just bring over our symbols to one side. So let me just double check something. Okay, so what we do is we notice we have x squared on both sides. We can just take them away. And now let's bring all our x's to one side. So we have 3x is equal to, then we have negative 28 minus 8, which is minus 36. So if we divide both sides by 3, we're going to get x is equal to negative 12. And that will be our final answer. Now, in these questions, in these solve questions where you have something like this, so if I rub out all this, I'll rub out some of this working, so I have some space to write. So what we've done is we found x to be negative 12. Now we can actually check our answer to see if it's correct. All we need to do is sub in x as negative 12 into this original thing. So if we did that, we would hope to get we'd hope to get 1, because that's what our original equation said. So if you just sub that in and you get 1, then you know you've done the right thing. So that's just a quick check you can do to make sure you've done it right. Anyway, moving on from that, we have this one here. So this is a simplifying one. So we're told to simplify 4x minus 8x squared over 12x minus 6. So what you want to do in these ones is you want to get common factors on the top and bottom that you can then divide by, so you can cancel them out. So if we look at the top of this fraction, what do we have that what is something that we can take out as a factor? Well, notice both of these numbers are multiplied by x. So first of all, we can take x out as a factor. So we have x lots of 4 minus 8x. So we have this thing right here. Now another thing we can do is, if I write it down here, we can take out 2 as a factor from the bottom and top. So we have 2 lots of x is 2 minus 4x, and then that's divided by 2 lots of 6x minus 3. Now if you notice, we have 2 on the top and bottom, so we can just cancel out these 2's, and we're left with x lots of 2 minus 4x divided by 6x minus 3. And what you can do here is just simplify it one more step, because you can take out 2 as a factor again from the top. So we have 2x is 1 minus 2x, and then that is divided by 6x minus 3. And that will be our most simplified form, and we just leave our answer like this. So this is the simplified form. Moving along, we have another thing, which is rearranging equations. So this whole thing on algebra, I'd say, is very important, because they come up in every question basically, one way or another. So this is an important thing where we're told rearrange this to make x the subject. So if I just write it down. So in these questions, all you want to do is you want to somehow get all your terms with x, because that's what we're making the subject. We want to bring all our x terms to one side of the equation. So first of all, if you notice, we have a fraction, so we want to get rid of that. So multiply both sides by x. So we get yx equals 5x plus 9. Now the next step is, like I said, we want to bring all our x's to one side of the equation. So we take away 5x from both sides. So we have yx minus 5x is equal to 9. And now notice what you can do. You have x in both of the terms, so you can take it out as a factor. So you have x lots of y minus 5 equals 9. And then at this stage, all you need to do is just divide both sides by y minus 5. So you get x is equal to 9 over y minus 5. And then that would be your final answer. So that's all you need to do for these ones. What you do is first whatever you're making the subject, bring that to one side of the equation, then you might have to factor it out, and then you just divide. So you just get to your final answer that way. Let's move on to the next question now. Let me just double check what we had next. Okay. So this next question is this one right here. Okay. So this question, we're being asked to sketch the graph of y equals 2x squared minus 8x minus 5, and we're told to show the coordinates of turning points and any intercepts with the coordinate axes. So this is basically as hard as quadratic related stuff will get, sketching a graph fully. So what you need to do for these ones is, I'll sort of write them out. So here are the steps you need to do. So first you want to factorize the quadratic. So for these ones where it says show the coordinates of the turning point as well, what we want to do first is complete this square. So we want to put it in completed square form. Next, what we want to do is basically put this on a graph. So then we sketch the graph. And the graph is going to look one of two shapes. So either it will be this sort of U shape, or it will be this upside down U shape. And the way we decide this is whether the number in front of the x squared is positive or negative. So in this case it's positive, so we have this sort of graph. So now we're going to go about the steps. So we know the graph is going to look like this. So now we do what I said. So that is completing the square. So how do we complete the square on this right here? So for completing the square, the first thing you want is generally to have the number in front of the x squared to just be 1. And right now, if you notice, we don't have that. So all we're going to do to make it 1 is we take out 2 as a factor of the whole thing. So we have 2 lots of x squared minus 4x minus 5 over 2. So now that we've factorized 2 out, we notice we have a 1 in front of the x squared. So this 2 is just going to stay here, and we're just going to ignore it for now. So looking at what's on the inside, we have this thing right here. So the way you complete the square is you have x minus something all squared, or plus something, and the way you decide that is you look at this coefficient in front of the x and then you half it. So we have minus 4, we half that, we get minus 2. So we have x minus 2 all squared, and then we have to add on something to balance it out. So we have, if we look at this, so we have x minus 2 all squared minus 5 over 2. And now we want to also make sure these two equations are equal to each other. Now notice, if we expanded this thing out, we're going to get x squared minus 4x, but we're also going to get a plus 4, which was not in our original equation. So to balance it out, we're going to take away that 4. So from this equation, we just take away 4. So this will be our completed square. So if we simplify minus 5 over 2, take away 4, we're going to get minus 13 over 2. So if I just write it here. So that will be our completed square form. But remember, we had this 2, so we just bring it back into the brackets. So this is our final completed square form. Now what we do is we use this to help sketch our graph. So what completed square form does, it allows us to solve the quadratic easily, but it also allows us to find the turning points very easily as well. So first of all, let's look at solving the quadratic. So if I rub out all of this, so I'm just going to write the completed square form next to here, just so that we can see it easily. So we have this. So let's go about solving the quadratic. So to solve a quadratic, you just need to set it equal to 0. So we have this whole thing equal to 0. First of all, we can divide by 2. So we're left with this equaling 0. So if we add on 13 over 2 to the other side, we have this thing right here, and we can square root both sides. So we get rid of that square, and what we have here is the square root of that. So our solutions, but remember, when we square root something, we have to get plus or minus. So now we have x minus 2 equals plus or minus root 13 over root 2. So our solutions are going to be x equals 2 plus or minus, so I'll just write the root like this, root 13 over 2. So these are going to be our solutions to the quadratic. So the solutions of the quadratic represent where our graph crosses the y-axis. Is it the y-axis? Sorry, where it crosses the x-axis, I meant. So if we draw a quick graph thing here, so now we can sort of sketch the graph. So we need to, first of all, so this 2 plus or minus root 13 over 2, it's going to be where the graph is here. So if I just put them both here. So this is 2 minus root 13 over 2. And this is 2 plus root 13 over 2. And remember what we said, our quadratic is going to have a U shape because it's a positive quadratic. So it's going to look something like that. Now all we need to do is find this coordinate. So this is the turning point. And the way we do that is we look at our completed square form. And what we do is to find the x coordinate of it. So if I get rid of this, to find the x coordinate, all we need to do is set this thing here equal to 0. So that will be x minus 2 equals 0, so x equals 2. So the x coordinate will be 2, and the y coordinate will be, if this is equal to 0, we see what we're left over with. So we have 2 times minus 13 over 2, which is just minus 13. So this will be the coordinates of our minimum point. And that will be our final answer. And yes, that, as someone pointed out, we definitely do need to show the y-intercept as well, which is something I forgot. So the y-intercept is just this constant here, so it's 0 minus 5. And then that will give you all the marks. So this was definitely a longer question and more difficult. These ones, if it were to appear, it'd be right at the end of the paper, to be honest. Like, that's where I'd say it would be. Now, while we're on the topic of quadratic graphs, I'll just point out something else that they could also ask. So if I use a different color for this, sometimes what they could ask is to solve an inequality. So let's say, if I go over here, let's say we were told to solve this inequality. So let's say it said where our graph is greater than 0. So the way we would do that is, first of all, we'd sketch our graph. Now we don't need to sketch it as much detail as we did in this question, but we'd basically sketch it, and the important thing is we just know these coordinates, so where it crosses the x-axis. Once we've sketched it, what we do is look at if we're looking at greater than 0 or less than 0. So in this case, we have what we're told we're looking for is when our graph is greater than 0. So greater than 0 means we're above the y-axis, we're on the top half. So if it was asking for where x is greater than 0, we would just have those highlighted parts, which would give us when x is greater than this, so 2 plus root 13 over 2, and when x is less than this coordinate here, so less than 2 minus root 13 over 2. Now if it asked something else, so let's say it said find where it's less than 0, then all that would mean is when it's under the y-axis. So it'd be this blue highlighted part. So that's all you need to remember for solving the inequalities. So now that we've done that, let's move on. So let's see what our next question was. Okay, so now we have simultaneous equations. So if we look at this, okay, so here we have quadratic simultaneous equations. Now the way you solve these is slightly different to normal simultaneous equations, but all you need to do is, first of all, you look at your linear your linear equation. You look at the one with no squares in it. So if we look at this, what we want to do is sub in this into that equation. So what I mean by that is we're either going to make this bottom equation as y equals something or x equals something. So what we're going to do is rearrange it like this for this one. So we have y equals 13 plus 3x. So all we can do now is, if we look at this equation, we are going to sub in this y into that equation there. So we have x squared plus y squared, but instead of y squared, we're going to replace the y with this right here. So we have 13 plus 3x, and remember it's all being squared, and that is equal to 25. So this live, by the way, it's probably going to be on until around 7 o'clock, maybe until 7:30, but I'm not too sure. But I'll try and get as much content done as I can, but we probably won't be able to get everything done. It's taking a bit longer than I thought. But I reckon, let's say another half an hour will go on for. So anyway, let's continue with this question. Now that we've done this, we just expand the bracket. So we have x squared plus, so we have 9x squared, and then that is plus 78x plus 169 equals 25. And now we can simplify this a bit. So let me just double check I've done this right. Okay, so we have 10x squared plus 78x, and then we can take away this 25 to that side. So we have 169 take away 25, so 144, and that's equal to 0. So what we do here is we have a quadratic. Like I said, quadratics is basically guaranteed to appear in your paper, so make sure you're confident with solving them. So to do this, first we're going to try and make it look a bit simpler. So we're going to, if you notice, we can divide everything by 2. So we have this right here. So 144 divided by 2 is 72. And now we can't simplify this any further. Now this, looking at this, it seems like it's going to be annoying to solve. So what we're going to do is just use the quadratic formula. So if we go over here, so for the quadratic formula, our b is equal to 39, c is 72, and a is 5. So, okay, it can't be seen fully. Let me just zoom out a bit. Okay, that should sort it out. So now we're just going to use the quadratic formula, which I'll just write in case anyone's forgotten. So it looks like this. The quadratic formula will be your best friend in the exam, basically. You'll probably have to use it, realistically. So make sure you know it and you know how to use it, more importantly. So now that we've written this, let's actually use it. So we have x is equal to, so minus b, that's minus 39, and then plus or minus b squared, which is 39 squared, minus 4ac, so 4 times 5 times 72, and then that is all being divided by 2 lots of a. So, and yeah, this is non-calculator, by the way. So this one is a bit of an annoying question to be on a non-calculator, but it's, yeah, so this is in preparation for tomorrow's exam mostly. So as you can see, this is quite annoying to find. we have 39 squared, which we're just gonna use multiplication, like long multiplication, to find it. So that is gonna be 81, so 27. So basically I'll just quickly do it here, but I'm sure you guys know how to do this in the exam, and I hope I haven't done it wrong, but that will give us something like this, I believe. Let me double check. Yep, 1521. So if I rub out this working out, in the exam obviously show you working out, but what we have here is x equals negative 39 plus or minus 1521 take away 4 times 5 times 72. So that's 20 times 72, which is the same as 2 times 720, which is 1440. And that is being divided by 10. So if I rub out this, now what we have is just a matter of simplifying this. So we have x equals negative 39 plus or minus, let's find out what this is. So this will be 81, and that's divided by 10. And I'm sure you know the square root of 81 is just 9, so we're going to replace that with 9. So now we just do for the plus case and for the minus. So we have x equals and x equals. So if we do plus 9, we have x equals minus 30 over 10, so x equals minus 3. And if we do minus 9, then we have minus 48 over 10, so minus 4.8, I believe. Let me just see. Okay, yeah. Now that we've done that, we just need to find our corresponding y values. So if I rub out some writing here as well. So once we found the x values, we just find the y values that match those. So for x equals minus 3, we can just use this equation to find it. So we have y equals 13 plus 3 lots of minus 3, and that will just give us y is equal to 4. So we have this as one solution, and now we can sub in x equals minus 4.8, which gives us, so if we then sub in x equals minus 4.8 here, we're gonna get y as being equal to minus 1.4, and those will be our solutions. So this was a bit of a long question again, but these ones are quite annoying, I'll be honest. Yep, so for quadratic simultaneous equations, you're almost always going to get a double set of values. Like you're going to get 2 pairs of values. Sometimes it won't be like that, but whenever you see quadratic ones, it's very likely you will get it. So if you get 2 x values, then you're going to get 2 y values as well. So it's just something to bear in mind. So if we move away from that, now we go on to this right here. Okay. So this question is on geometric series, and first of all we're given the first 5 terms of a geometric series, and we want to work out the next term of this sequence. So what you need to remember for geometric series is that the rule for them is to go from one term to the next term, you're just multiplying by some constant number. So just like how for nth term you're just adding something for each term, for geometric series you're multiplying by some number each time. It's the same number each time, by the way. So what we need to do is just find out what this number is that we're multiplying by, because in part A we're told to work out the next term of the sequence. So if we look at the first 2 terms, for example, we have root 5 and then 10. So we know that to go from root 5 to 10, we're multiplying by something. Let's call this something x. So that means x times by root 5 is equal to 10. So now we can just find out what this x is equal to, which is 10 over root 5, Now we can simplify this, we can rationalize this third. So we can multiply the top and bottom by root 5. It's not completely necessary you do this, but you can do that. So once you do that, you're going to get 10 root 5 on the top, and then on the bottom you're going to get 5, which can be simplified to 2 root 5. So x is just equal to 2 root 5. So that means in this sequence, to go from one term to the next, we multiply by 2 root 5. So now the question says work out the next term. So we want to work out the next term after this. So all we need to do is we take this term and multiply it by 2 root 5. And that is just going to be, so first we look at the integer part. So we have 800. Then we have root 5 times by root 5. So we have root 5 squared, which is the same as just 5. So we have 800 times 5. So the next term will just be 4000 in this sequence. So that's part A done. Now let's look at part B. If I scroll down slightly so we can see everything. Okay, I'm just making sure the stuff don't go off screen. Okay, so in part B we're told we're dealing with a different geometric series now. So the fourth term of a geometric series is this, and the sixth term is this. And we're told, given that all the terms are positive, find the first term of this sequence. So this is, when we have questions like this, what I like to do is sort of think about what we done in part A that could be helpful in part B. So what I'm going to do is just write out the blank spots for this geometric series. So we're told the fourth term is 5 root 2 over 4, and the sixth term is 5 root 2 over 8. So we don't know what the first, second, third, or fifth terms are, but we want to work out the first term. Now, how we're going to do this? Well, we're going to think about how you generate terms of a geometric sequence. So if we look at part A, how did we get this second term? Well, we just multiplied by 2 root 5. Let's think about how we got this third term. So this third term was done by multiplying by 2 root 5 again. And what have I done? That's not great. Okay. Back to what I was waffling on about. Let me get that. Okay. Now that I've scrolled back. So what I was basically saying is we just multiplied by 2 root 5 to go from one term to the next. So if we look at this thing, let's try and find the constant let's try and find the multiplying factor in this geometric series to go from one term to the next. Because notice you can actually work backwards from a geometric series as well, because to go from the first term to the next term you multiply by 2 root 5, but if you wanted to go from the second term backwards to the first term, you just divide by 2 root 5. So you can actually go in the backwards direction as well by just dividing by the multiplying factor. So what we're going to do here is let's label our multiplying factor x again. Then how to go from this term to this term? Well, what we do is first we multiply this by x. So we do 5 root 2 over 4 multiplied by x. Then we're given, once we do that, we reach this term. Now to get to this term, we're going to multiply it by x again. So we have 5 root 2 over 4 times by x 2 times. So this is the same as saying 5 root 2 x squared. And then we will reach our sixth term. So to go from the fourth term to the sixth term, we just multiplied by our multiplying factor 2 times. So if I scroll down here, now all we need to do is just solve this for x. So how could we do this? Well, we can first of all multiply both sides by 8 to just get rid of the fractions. So on this left side we have 10 root 2 x squared, and on the right side we have 5 root 2. So we can divide both sides by root 2. That will give us 10x squared equals 5. Now you can divide both sides by 10 and you're left with x squared equals a half. Now we can find x, so we square root and we get x equals plus or minus 1 over root 2. But the reason, so we have plus or minus 1 over root 2, but we need to decide if it's plus or minus. And this is where this statement comes important. So it says, given that the terms of this sequence are all positive, that means we're going to take the plus 1 over root 2. Because if it was negative, then that means we'd get some negative terms in our sequence. So our multiplying term has to be positive. So now that we've found our multiplying term, we're just going to work backwards to find the first term. So to go from the fourth term to the third term, we're going to divide by x. To do that again, we're going to divide by x one more time. And to reach the first term, we're going to divide by x again. So in total, we're dividing by x 3 times in a row. So we're dividing by x cubed in that sense. So to go from the fourth term to the first term, all we do is 5 root 2 over 4 divided by x cubed. So that is 1 over root 2 all cubed. So if I scroll down, let's try and actually calculate that. So 5 root 2 over 4, we have this here. And then we have divided by 1 over root 2 cubed. So what is 1 over root 2 cubed? So let's just look at what root 2 cubed is. So first of all, let's square it. So root 2 squared is 2. And we just need to square that. We need to multiply that by root 2. So root 2 cubed is 2 root 2. Because we just have this thing here. I should have written it like this, would make more sense. So we have this, these two combine to get 2, and then we have root 2 remaining. So this is equal to that. Now we have one fraction divided by another one, and you just need to remember how you multiply fractions. Well, you just change this division sign to a times, and then you flip this fraction. So if we flip it, we're just going to get 2 root 2. So our first term is going to be those two multiplied by each other, which is going to give us 10 root 2 times root 2 over 4. So the root 2's will combine, so you have root 2 squared, which is just 2. So 10 times 2, 20 over 4, and that is 5. So our first term of the sequence will just be 5. So that will be our final answer. It feels a bit weird how we have all these surds and then our first term is actually just an integer, but I guess that's how it is. So moving on from that, these questions are quite difficult, I'll be honest. So that previous one I'd say is a grade 9. So if you could do that, especially the part B, then you should be on for a very good position tomorrow. So moving on, we have another important thing, which is functions. So I'm going to be honest, functions, I'd say it's a hard topic, but once you practice them, it's not bad because they're the same thing over and over again. And with functions, there are a few important things to know how to do. One of them is the part A of this question, which is finding the inverse function. So all you need to do to find the inverse function is, so we look at this, fx equals 3x minus 1. So our first step is, so step 1, we say let y equal 3x minus 1. So we just replace the fx with another letter, so we just say y. Now that we have this, what we do is we rearrange this equation to make x the subject. So if we rearrange this, we're going to get y plus 1 equals 3x, and then we can divide both sides by 3. So we have y plus 1 over 3 is equal to x. Now what we do at this stage is, this will be our inverse function, but we just replace the y with an x. So f minus 1 of x is equal to, sorry, not y plus 1, x plus 1 over 3. So for the inverse functions, what you do is you let the function equal a different letter, then you rearrange to make x the subject, and then you just replace x back in with that, and that's your inverse function. So that's part A done. Now looking at part D, we're told, given that fg of x is equal to 2g f of x, we want to show that this equation. So basically we want to do this and do some simplifying and show that it's equal to that. So if we start off with that, sorry about that, my phone went off, let me just mute that. Okay, so looking at this, let's look at the left hand side. So how do we find fg of x? Well, this is an important thing for functions of how to do that. So functions work from the right to the left. So fg of x means we're taking g and subbing that into f. So what I mean by that is fg of x is f of x. So if I rub this up, so fg of x is saying we're doing f of x, but instead of x, we're replacing it with g of x, which is this. So we're writing 3 lots of x minus 1, but instead of the x, we're replacing it with what gx is, which is x squared plus 4, and then minus 1. Now gf of x is the other way round. So we're taking f and subbing it into g. So you take the right thing and sub it into the left thing. So we take f, which is 3x minus 1, and sub it into the x for g. So we have 3x minus 1, which is this thing here, all squared, and then obviously you just plus 4. So now you have these two things, and we use this fact. We're told given that fgx is equal to 2gf of x. So this is saying 3x squared plus 4 minus 1 is equal to 2 lots of this. So 2 lots of, if I write it correctly, 2 lots of that. Have I written correctly? Yep, okay. So we're saying given that this, and now what we want to do is just expand this, simplify, collect like terms, and show that we get this. So if we expand the left side, we have 3x squared plus 12 and then minus 1, so plus 11. And then on the right hand side we have 9x squared minus 6x plus 5. So we can simplify this a bit. So we have on the left side 3x squared plus 11 is equal to 18x squared minus 12x plus 10. So now we just simplify this. So we can take everything to the right hand side. So we take away 3x squared, we have 15x squared, then we have minus 12x, and then we're taking away 11. So 10 take away 11 is minus 1, and that is equal to 0. And as you can see, we have shown exactly what they wanted. So that will just be our final answer, and we're done with that question. So that is where you'd leave this question at. So that would be the final thing here. So as you can see, these ones, it's just algebra. A lot of expanding brackets, simplifying. Like, if I were to say anything that is literally crucial to do good in the exams, it's being very confident with your algebra. So you need to be able to expand stuff, simplify, solve quadratics, do all those stuff very fluently, because it gets used in every topic, every question basically. So if we move on to the next set of, had some more questions. So what we have now is, if I go here, so now we have function transformations. Let me make sure it can all be visible. Okay, so in this first question we have a graph showing y of f of x, and we're told on the grid to draw the graph with equation y equals fx plus 1 minus 3. So this is, let me just zoom in a bit. So sorry, it's a bit blurry, but hopefully you guys can see what it says. I'm not sure if you can. It is very blurry actually. So I'll try and zoom in as much as possible. Okay, yeah. So this is for part A. We want to draw fx plus 1 minus 3. So let's look at this question. So for function transformations, there's two key points. So what there is what we're doing to the f of x, so what we're doing to the x, and then what we do to the extra thing. So for this, when we have minus 3, so outside of the f, then that means the whole thing is going down by 3 places. So that means this graph is getting shifted down by 3 places. And what this thing inside means, so x plus 1, this, because we're adding 1, this means we're shifting 1 to the left of the x direction. So if we look at each thing one by one, first of all, let's look at fx minus 3. So what that does, like I said, it shifts it 3 down. So it's going to look something like this. So that's fx minus 1. Now what we want is fx plus 1 minus 3. So now we're going to do this transformation. So we're going to do x plus 1. Now like I said, this shifts us 1 in the left direction. So we go 1 to the left in the x direction, which means we're basically going to get the same graph, just shifted slightly to the left. So if I rub this one out, we're going to get this thing. Okay, so we're going to get this like that. I'm trying to do this correctly. So we end up getting this thing right here. So basically in exam, I'd recommend that you do each thing individually and then you get the final thing. So once we've done part A, we have part B, which is saying the point a2 minus 2, 1 lies on the graph of y equals f of x. And we're told when this graph f of x is transformed to y equals f of minus x, point A is mapped to point B. We want to find the coordinates of point B. So what we do for this is just look at, so I'll just explain. So here we have A minus 2, 1. So this is the coordinates of A. And we're told A is on f of x. And we're told what happens to A when we do f of minus x. Well, notice the difference between these two is we're just putting a minus in front of the x. So we're just doing the negative of the x value. So A is just going to be this x coordinate, but the negative of it. So minus 2 will just be positive 2. So the coordinate of, sorry, not A, the coordinate that we're transforming to B will just be A, but we negate this minus 2, which gives us 2, and that will be the coordinates of B. So 2, 1. So I'll try and, because we are going a bit late on the time, I'll look at a geometry based question. I think I had some, if I can find it. So if I see where it was, okay, yeah. So I had some geometry based questions and we'll try and look at them. So here is a difficult one that I'd say. This one is quite difficult, but it is important. So if we look at this one, so we have two shapes, like shaded regions A and B, and we're told shape A is made by basically taking a sector and removing a piece from it. And we're also told shape B is a circle, and we're given basically the radiuses and stuff in terms of x. We're told the area of shape A is equal to the area of shape B. So these two shaded regions are equal to each other. And what we want to do is find the value of x. So what we're going to do for this question is, first of all, we're going to find an equation giving us the area of A, and then we're going to find an equation giving us the area of B, and then we're going to set them equal to each other. So if we look at the easier one first of all, how do we find the area of B in terms of x? Well, if I write B here for the area of B, so actually I'll just write area B. So B is just a circle, and the area of a circle is given by pi times the radius squared. So in this circle, if you notice, we're not given the radius, but we're given the diameter, because this is going all the way across the circle. So to get the radius, we just half it. So we do 2 minus 2x all divided by 2, which is 1 minus x. So this is our radius. So this is r. So to get the area of B, we just do pi times r squared. So pi times the radius squared, which is this right here. So that's the area of B. So now we've done the easier bit, we have to do the harder bit, which is find the area of A. So if I go over here, so to find the area of A, what we're gonna do is, let me think what we should do. So to find the area of A, so everyone's saying, are we cooked or is it over? Well, I guess you'll find out tomorrow. Maybe if the exam's bad, hopefully the exam goes good, but let me know, guys, how it goes tomorrow. Hopefully it goes good. Hopefully Edexcel or whatever exam board you're doing decide to give an easy paper, but you never know, they could give horrible questions. But I guess all you can do is hope for the best. So anyway, looking at this, let's find a plan to find the area of A. So what we have for A is this sort of thing. So we have, this is the shaded area A. The way we're going to find it is by first of all working out the area of the big sector, and then we're going to take away the area of that little sector, because that will give the shaded region. Because first we're finding this area, then we take it away from that little area. So let's call this, actually let's not call them anything, but let's find each of those two sectors that I've said. So first of all, let's recall the formula for area of a sector, which is pi r squared divided by, wait a second, so it's pi r squared multiplied by theta over 360. So what I mean by theta is just the angle, so the angle of the sector. So now that we've got the area of a sector, so for working out what I'd say, so basically someone's asking, do they actually check your answers if you're working out correct? What I'd recommend is obviously to write your working out, but to be honest, sometimes for some questions, if you get the answer correct and your working out's a bit messy and stuff, you should get the full marks. However, in some questions where they say show that something, then in that case it's very important to show all your working out. But in general, I'd say if you get the right answer, as long as you've done working out, even if it's a bit messy and stuff, you should get the full marks. But I'd recommend putting all your working out down, because sometimes, let's say you make a mistake in the question, but your working out is correct, then you're still going to get some marks, because the examiner can see you had the right idea, but you just made a silly mistake. So do the working out, but if you get a right answer, don't be worried that you'll lose marks because your working out was messy or something. But obviously, I just recommend do all your working out. That's my main advice. So also for any areas that I recommend to prioritize for a good mark is basically it's pretty close to the exam now, so I just quick, just make sure you know all the content. Maybe look at past papers, certain questions you find more difficult, and just be very confident with your algebra stuff. So being able to solve quadratics, simplify stuff, factorize, all those things basically. But all I can say is just good luck for the exam. And one thing I would say, since this is the first paper, even if it goes really badly, don't be put off by it, because there's still 2 more papers in maths, obviously. So even if paper 1 doesn't go too good, still keep trying, because you still have 2 more papers. And if you find the paper really hard, then chances are everyone else is also finding it hard, so it sort of balances it out. Because if everyone finds the paper hard, the grade boundaries will be lower. So if you find the paper really difficult, don't be put off. Just know that everyone else is probably in the same position as you. So that's basically what I'd say for that. Now, enough waffle. Let's look back at this question. So what we're trying to do is find the area of A. So what I said we're going to do is find the area of A by finding the large sector and taking it away from the small sector. So the large sector has a radius of, notice we just add those 2 up, so 5x minus 1, and the small sector has a radius of 3x minus 1. So both of them have 45 degrees. So I've just written 45, hopefully that's readable. Now what we're going to do is just sub in this into our formula. So the area of A is equal to, so this is for the big sector, so pi times radius squared, which is 5x minus 1 squared, and then we multiply by theta, which is 45 over 360, and then we take it away from the area of the little sector, so that's pi times 3x minus 1 squared multiplied by 45 over 360. Now at this stage, you can probably simplify 45 over 360, and that will just give you, so notice you can divide the top and bottom by 45, which will give you 1 over 8. So if I just get rid of this, so in the next stage of working out, we'll just replace it with 1 over 8. If I scroll down a bit, okay, I'm just going to scroll down a bit so there's more space for working out. But now what we need to do is just simplify this. So like I said, these simplify to 1 over 8. So we have 1 over 8 pi times 5x minus 1 squared, which we're going to expand. So that's 25x squared minus 10x plus 1. And then we have minus an 8th pi 9x squared minus 6x plus 1. So this very long, horrible looking thing is what the area of A is equal to. Now we could simplify this further, but I'm not going to quite yet, because if I just bring this up a bit, so this is the area of A. So let me get the pen. Okay, so area of A is equal to that, and we're told the area of A is equal to the area of B. So let's set these two things equal to each other. So we've already found the area of B, it's that. So if we set these two equal to each other, then we can just do some sort of simplifying and stuff and try to get an answer. So if you notice, we have a pi in every term, so we can divide both sides of the equation by pi, which will get rid of all those 3 pi's. And then we also have an 8th in both of those terms, so we can multiply both sides by 8 to get rid of the fraction. So on this side of the equation, we have 8 times 1 minus x all squared, and then on the right side we have this thing right here. Yeah, okay. So now that we have this, all we need to do is just simplify this and collect the like terms. So if we simplify the left hand side, we have 16x squared. Then this is minus and a minus 6x, so that's plus 6x. So we have minus 4x and then plus 1 and minus 1, so they cancel each other. And then on this side we have 8 lots of x squared minus 2x plus 1. So now we just expand this bracket. So we have 16x squared minus 4x is equal to 8x squared minus 16x plus 8. So now what we can do is just bring all our terms to one side of the equation. So we have 8x squared, we're bringing everything over to the left hand side. So we have 8x squared plus 12x minus 8. And I'm just checking if this is correct. Hopefully I haven't done anything wrong. Okay, so now that we have this, we can just try and get to solving this. So notice first of all we can divide both sides. We can divide everything by 2. So we have 4x squared. Actually, we can divide everything by 4, which will give us 2x squared plus 3x minus 2 is equal to 0. Now at this stage, you have a quadratic. Like I said, quadratics will literally appear all the time in your paper. Like, I can almost guarantee it, you're going to get a quadratic in your paper. You're going to have to solve it at least once. So let's solve this one. So what I'm going to do is just use the quadratic formula. So b is, okay, let me scroll down a bit so you can see everything. B is 3, C is minus 2, and A is 2. Now you just sub that into your quadratic formula. Then you have this thing right here. So I'm just writing it quickly because we've written the quadratic formula so many times already. And then once you simplify that, you have this. So you have square root of 1, which is just 1. So I'm just going to get rid of that square root sign and then divide by 4. So now we get two solutions. When x is equal, have I done something wrong? Feel like I've done something wrong. Let me just see. Yeah, I've simplified something wrong. Let me just double check this. So, oh yes, this is not square root of 1. This is square root of 9 plus. So to be honest, you can use it doesn't, I'm just using a quadratic formula for this, but you can also use just the grouping method. For most cases you can use whichever one to solve it, but I just prefer the quadratic formula because I find it a bit quicker. But if you prefer to use the grouping method, then you can do that. Sometimes you will have to use the quadratic formula, and that is when your solution is like not nice solutions, when you get something like x equals root 2 or something like that. But in most cases, if you try and use the grouping method and you see it doesn't work, then that probably means you have to use the quadratic formula. So what I'd say is you can always use the quadratic formula and you can sometimes use the grouping method. So you can try the grouping method, but I just prefer the quadratic formula. Both would work for this question, by the way. So if I just put it in correctly and solve this, we have square root of 25, I believe. Yeah. So now we have two solutions for this. So we have x equals 2 over 4, so a half, and then we also have x equals negative 2. Now, if we remember what x actually represents, because it feels like we've been doing this question forever, x is representing, so if we look at the circle, for example, 2 minus 2x is telling us the diameter of a circle. So we want to decide whether x is equal to a half or x is equal to negative 2. So what would happen if x was equal to a half? Well, if x was equal to a half, then we'd get the diameter of this circle as 2 lots of minus 2 times a half. So that's equal to 1. So there's no problems right now. But let's see if it works for that. I'm just double checking. But if x was equal to minus 2, let's see if that also works. So if I go over here. So it works for this circle, clearly, both of them work. But let's look at this one here. So this circle has 2 radiuses. So let me word this a bit more correctly. But if we look at this sector here, we notice one of the measurements is given as 2x. So if a measurement is given as 2x, then can it make sense for x to equal minus 2? Like, if x was equal to minus 2, then that would mean this part is equal to minus 4, which does not make sense in terms of measurements. So because of that, we're not going to choose this solution. We're only going to choose x equals a half. So that would be our final answer for this one. And this one was quite a long question. So if you managed to keep up with what I was saying, that's very impressive, I'd say. This one definitely would be on the grade 9 side. One thing I'd recommend, if this sort of stuff does come up in your paper, even if you feel like what the hell's going on, at least have a go at the beginning of the question, because you can pick up some marks then. So for example, what we did, finding the area of B, that's not too difficult. So you could at least try that, maybe get 1 or 2 marks. Because in the more difficult questions, it's the beginning marks that are easy to get, but the 4th, 5th marks are the hardest to get. So if you start the question, you may get 1 or 2 easy marks. Even if you don't finish it, it's alright. So now that we've finished this question as well, it's been quite a while, and I said I'd finish around 7:30, so I think this would be a good time to end the stream. I was just going to say, do you guys have any questions or anything before we wrap up this live stream? All I'll say also is good luck for your exams tomorrow. Hopefully it goes fine. So if we just... This was our last question. What I'd recommend also before your exam, the night before, is probably just get good sleep tonight. Make sure you're well rested. Probably don't try and pull an all-nighter because you'll be very knackered for your exam. No problem, guys. You're very welcome. Thank you all for watching. I hope this helps. Hopefully some of the stuff I explained comes up in the exam. But I think I'll end it here anyway now. So very best of luck for you guys tomorrow, and I'd appreciate if you could subscribe if you weren't subscribed already, and maybe like this stream. But thank you for watching, guys, and I'll see you if I do another live stream maybe. But good luck with your exams.